The question is, in a certain ideal transformer, the current in the secondary coil, so I will keep writing alongside, is 4 times as large as the current in the primary coil. So this is given. Which row of the table correctly identifies the type of transformer and the ratio of turns? So we have to select which option is correct. And we have to remember one thing, that step up or step down, it's easy to remember with reference to the voltage. So that means we need to find the voltage, but voltage is not given. So you should remember the formula. Voltage in the secondary divided by voltage in the primary will be equal to number of turns in the secondary divided by number of turns in the primary, which in turn is equal to the current in the primary divided by the current in the secondary. So current in the primary divided by current in the secondary from here will be equal to 1 divided by 4. So whether it is a step up or step down will be decided by the Vs. Yeah. So from here we have voltage in the primary is equal to 4 times the voltage in the secondary. So since voltage in the primary is greater than the voltage in the secondary, therefore it is a step down transformer. Yeah. So I will use some shortcuts. It's a step down transformer. So either option C or D is correct. But at the same time, we also have to comment on the ratio of turns in primary coil to the ratio of turns in the secondary. So it's very clear if you see from here. So from here we get number of turns in the primary divided by number of turns in the secondary will be equal to 4:1. So it is definitely a step down and with a ratio of 4:1, and therefore the option C is correct. So a few things you need to remember whenever we call it as a step up, it is with reference to the voltages. So for a step up, the voltage in the secondary has to be higher than the voltage in the primary, and accordingly you can conclude based on the number of turns and also the current. So that's the definition of step up, and also the question also says that it is a ideal transformer. So just a piece of advice, does it really matter in this question if it is an ideal or a non-ideal transformer? With ideal transformer, the power in the input circuit or in the primary will be equal to the power in the secondary circuit. But in this question, it doesn't really make any difference. Even if there are some losses, which means it is not a 100% efficient transformer, our formulas still hold good.